Lesson 14.16 is solving compound interest functions. It says Sophie invested $420 in an account, pays an interest rate of 1.6%, and it's going to say compounded every so often, monthly in this case. Assuming no deposits or withdrawals are made, how long would it take to the nearest year for the value of the account to reach $570? So compound formula is that the final amount equals the principal times 1 plus the growth rate getting divided by, actually that shouldn't be t, that should be n. The number of times it's compounded, and then this should be n times t. I knew I was missing something here. Okay, so we've got that it's starting with her $420 she put in, times 1 plus, it's growing at 1.6%, change that into a decimal, so it'd be 0.016, divided by the number of times that it's getting compounded. Monthly would be 12 times in a year. And then that's raised to the 12 times in a year for how many years? So I'll put times t. That's what we'll solve for. And they want it to reach $570, which is not going to grow a whole lot, so we shouldn't get a very big number. So let's simplify just this part in the parentheses to get that to be some kind of base here for our exponent. I'm going to do the 0.016 divided by 12 and get that, and then add 1. So I get 420 times 1.0013. Repeating to the 12t power equals 570. And you know by now, don't erase anything out of your calculator. Now I want to get this exponential part isolated, so I'm going to have to divide away the 420. I might actually just leave that so I don't get too many decimals here. So then I'll have 1.0013 to the 12t power equaling 570 over 420. You could even drop the 0 off because you know you could divide both those numbers by 10. I think I'm going to do that. Okay, I'm ready to turn it into a log. Log with a base of this 1.0013 of 57 over 42 equals the power, which is 12t. Change the base right here. So I'm going to do log of 57 over 42 divided by log of this number. Gets me that. And then I know that I just have to divide that by 12. And it said to the nearest year. So that would be 19.1, which is still going to be just 19 years. Okay, number 2. Aubrey invested $16,000 into an account, paying an interest rate of 5.6%, compounded continuously. That's a big word that means very important, something very important to us. That automatically tells me that I'm going to do the amount equals the principal times e to the RT power. This is the PERT formula when it's compounded continuously. Assuming no deposits or withdrawals are made, how long would it take to the nearest tenth of a year for the value to reach 45,600? So she started with 16,000 times E, which is a number. The growth rate is 0.056. And then we're trying to find the time, so we'll do T. And we want to know when will that equal $45,600. That's going to have to stay in there for quite a while. Divide away the 16,000. Oh, that actually came out to be something nice. So e to the 0.056t equals 2.85. I'm going to change this into a log. So I've got log with a base e of 2.85 would equal 0.05t. Now log base e, to me it's a lot easier to just know that's natural log of 2.85. And this is going to get a number on my calculator. So I'm going to hit natural log button, which is right here. that. 1.0473-ish equals 0.05 t. So divide by 0.05. Oh, did I lose my 0.056? Hold on. Oops. Let me divide by 0.056. And it wanted to the nearest tenth, so that would be 18.7 years.